Welcome to the podcast, Even More Absolute Value Inequalities. In this podcast, we're going to look at what happens when you're solving an absolute value equation. Not inequalities. What happens when you're solving an absolute value equation and you've got x's on both sides. Before we only had x's on one side. We're going to use the same three steps, and you'll see that it's basically the same procedure. First, write the equation as absolute value of m equals k, that is, isolate the absolute value of m. And second, change the form to m equals k or m equals negative k, and note that there's no absolute value on the m now. We dropped that absolute value when we got to step 2, and finally solve for x. So let's start the first one. You can see the equation there. Absolute value of 2x minus 3 minus 2 is equal to 2x plus 3. Step 1 is isolate that absolute value. Get it by itself. So move the 2 to the other side. And that'll leave you absolute value of 2x minus 3 is equal to 2x plus 5. And now the second step is to write it in the form m equals k or m equals negative k. Here our m is 2x minus 3, our k is 2x plus 5. So we'll start off with m equals k. 2x minus 3 equals 2x plus 5, or m equals negative k, 2x minus 3 equals, and now be careful, you can't write here negative 2x plus 5 because that's not a negative on the whole 2x plus 5. That only puts a negative on the 2x. You have to do it this way. Put a bracket around it. Now it's negative all of 2x plus 5. Finishing on the left, subtract 2x from both sides. And look at the odd thing we get here. This is called a contradiction, and it leads us to no solutions. Now, that doesn't mean that there's no solutions to the problem. We still might get a solution out of the right side, so let's keep trying here. 2x minus 3 is equal to, distribute the negative, negative 2x minus 5. Now you can see why it's so important that that 2x plus 5 go in a bracket. Otherwise there'd be no negative on that 5. I'll bring the x's to the same side, bring my negative 2x over to the left, take my negative 3, move it over to the right. And so I'm left with 4x is equal to negative 2. I divide both sides by 4. And I get x is negative 1/2. Now, is that a legitimate solution? Well, let's try it out. Let's evaluate 2 times negative 1/2 minus 3, the absolute value of that, minus 2, and see what we get. Well, that's negative 1 minus 3, so that's the absolute value of negative 4 minus 2, so that's 4 minus 2, which is 2. Let's take a look at the other side. On the other side, we had 2x plus 3, so that's 2 times negative 1/2 plus 3. Well, that's also equal to 2. So that does check out, and that is a valid solution. Now, in our second example problem, not only do we have x's on both sides, we have absolute values on the both sides. But it turns out that even though technically that gives us 4 cases to consider, 2 of those cases duplicate each other. So all you really have to set up is 2x equals negative, or 2x equals x minus 3, or 2x equals negative x minus 3. And that actually covers, those 2 equations cover all 4 equations arising from the original problem. So let's solve the one on the left. We'll bring the x over to the left, so we get x equals negative 3. Let's just plug it in real fast here. That would be the absolute value of negative 6, which is 6 on the left, and that would be the absolute value of negative 6, which is 6 on the right. So that definitely is a valid solution. Now, again, just as in the last problem, it's crucial when you go to do the negative of the x minus 3, put that x minus 3 in a bracket. That's really important. because now you're distributing that negative and you actually get negative x plus 3. Bringing the negative x over to the left, you get 3x equals 3, x equals 1. Let's try it in. 2 times 1 is 2, absolute value of 2 is 2. 1 minus 3 is negative 2, but the absolute value of it gets rid of the negative. So again, we get 2 equals 2. Both of those are valid solutions. And that completes our podcast.